Everyone thinks the most terrifying predators in the ocean are the ones with the biggest teeth. The great white shark, the killer whale, the giant squid lurking in the darkness. But some of the most horrifying creatures in the ocean don't hunt with teeth at all. They don't chase, they don't ambush, and they don't need to overpower their victims. Instead, they do something far stranger. They move into another animal's body. They take control of part of it. And in one case, they actually replace an organ that the victim needs to survive. At first, that sounds impossible. How could a parasite become part of its host and not immediately kill it? Why would evolution create something so bizarre? And perhaps the strangest question of all, if this strategy is so effective, why don't more creatures do it? The answer begins with a small crustacean hiding in the ocean. A creature so disturbing that even experienced marine biologists sometimes struggle to believe it exists: the tongue-eating louse. Its name sounds exaggerated, like something invented for a horror movie. Except it's real, and somehow reality is even stranger. The tongue-eating louse starts life drifting through the water as a tiny larva. At this stage, it looks harmless, weak, almost insignificant, which raises a question: how does something so small become one of the ocean's most infamous parasites? The answer is patience. The larva drifts until it finds a fish, then it slips inside through the fish's gills. And this is where things get strange. Instead of feeding on random tissue, it has a specific destination: the mouth. Once inside, the parasite attaches itself to the fish's tongue. Not the jaw, not the throat, the tongue. It begins feeding on blood from the organ, day after day, week after week, until something extraordinary happens. The tongue slowly withers away. Its blood supply is cut off. The tissue dies. Eventually, the tongue disappears entirely. For most animals, losing an organ would be catastrophic. But evolution had a different plan. The parasite doesn't leave. Instead, it takes the tongue's place, literally. The louse anchors itself inside the mouth and remains there permanently. The fish now uses the parasite as a replacement tongue. Think about that for a moment. A living creature enters another animal's body, destroys an organ, then becomes the organ, and somehow both survive. At first, this sounds impossible. How could a fish continue eating with a parasite attached to the inside of its mouth? Scientists were shocked to discover that many infected fish continue living relatively normal lives. The parasite doesn't gain much if its host dies. So instead of destroying everything, it keeps the fish alive, which creates an unsettling partnership. The fish cannot remove the parasite. The parasite cannot survive without the fish, each trapped by the other. But that creates an even bigger issue. If this strategy works so well, why isn't every fish infected? Because becoming a parasite is far more difficult than becoming a predator. Predators only need to catch prey. Parasites need to infiltrate an entire body. They must bypass defenses, avoid immune systems, find nutrients, and keep the host alive. It's one of the most complex survival strategies in nature, which is why parasites have evolved some of the strangest abilities on Earth. Some control behavior, some manipulate hormones, some alter entire ecosystems. And nowhere are these evolutionary experiments more extreme than in the ocean. Deep beneath the surface, parasites are everywhere. Many remain undiscovered. Some scientists estimate that a huge percentage of ocean species may actually be parasitic at some point in their life cycle. That means countless creatures are engaged in biological battles we rarely see. Battles happening inside bodies, inside organs, inside tissues, entire wars hidden from view. And the tongue-eating louse is only one example. There are parasitic copepods that attach themselves to fish and grow bizarre branching structures through their flesh. Others burrow deep into muscles. Some parasites alter the appearance of their hosts so dramatically that they become almost unrecognizable. Which raises a question: why does evolution keep producing these nightmares? The answer lies in competition. The ocean is crowded. Every creature needs food. Every creature needs space. Every creature is fighting to survive. Predators compete with predators. Filter feeders compete with filter feeders. But parasites found a loophole. Instead of hunting food, they live inside it. At first glance, that sounds like an unbeatable strategy. Unlimited shelter, constant access to nutrients. protection from many predators, except there is a huge problem. Hosts fight back. Every animal has defenses, immune systems evolve, parasites evolve countermeasures, then hosts evolve new defenses, and the cycle repeats. For millions of years, this evolutionary arms race has produced some of the most bizarre life forms ever discovered. Creatures that seem less like animals and more like biological hacks. The tongue-eating louse is a perfect example. Its strategy sounds horrifying, but from evolution's perspective, it's incredibly efficient. Instead of constantly searching for food, it transforms its host into a permanent resource. Instead of risking energy hunting prey, it lets the host do the work. The fish swims, the fish searches, the fish survives, and the parasite benefits. But that creates another mystery. If parasites are so successful, why aren't they dominant? Why doesn't every ecosystem collapse under parasitic pressure? Because parasites depend on balance. Kill too many hosts, and they destroy their own future. Become too aggressive, and hosts evolve resistance. Become too weak, and competitors replace them. So evolution constantly pushes parasites toward a delicate middle ground. Not too deadly, not too harmless, just effective enough. And this balance has shaped life for hundreds of millions of years. In fact, some scientists argue that parasites may be among the most important drivers of evolution itself. Every time a host evolves a defense, parasites respond. Every adaptation creates another adaptation. Every improvement sparks another biological arms race. Without parasites, many species might look completely different today, including us. And that's what makes the tongue-eating louse so fascinating. Most people see a monster, a creature straight out of a nightmare. But evolution sees something else, a solution, an answer to a survival problem. The parasite didn't evolve to be horrifying, it evolved to survive. The horror is simply a side effect, and once you realize that, the ocean becomes much stranger, because the tongue-eating louse isn't an exception, it's evidence. Evidence that evolution doesn't care about what looks normal. It doesn't care about what seems cruel. It doesn't care about what makes us uncomfortable. It only cares about one thing: what works. And in the endless competition beneath the waves, some of the most successful strategies are also the most disturbing. That's why the ocean's most terrifying parasite exists. Not because nature wanted to create a monster, but because over millions of years, survival rewarded a creature that could do something almost unimaginable: replace a living tongue and turn another animal into its home. The next time you think about the dangers lurking in the ocean, you might picture sharks, giant squid, or massive predators from the deep. But some of the strangest threats aren't the ones chasing their victims. They're the ones quietly moving inside them, hidden from sight, patient, waiting, and proving that evolution can create things far stranger than any horror story humans could ever imagine.